Hey guys, it's Miss Hale here again. I am doing a refresher video on dividing fractions. Okay, so we are going to just go through a quick review. Dividing fractions. All right, so we're going to work on the standard algorithm here. All right, and just our little note that we should probably write on our paper is, we'll just put it over here, keep, whoops, sorry guys, change, flip, or KCF, okay? So keep, change, flip. All right, so we're going to divide, let's see here, 1/2 divided by 2. So the process here is that we need to make sure that we make both numbers look like fractions. So I expect for you to be making both of these numbers look like fractions. If you don't, it is very confusing when you go to flip that second number, okay? Because you're gonna keep this number the same, you're gonna change this operation to multiplication, and you're gonna flip this number. Do you understand how to flip 2 as a whole number? Well, you can't see it clearly unless it is created into a fraction, okay? So now we made both of our numbers look like fractions. We always put our whole number over 1. Why do we put our whole number over 1? We're going to ultimately end up multiplying this. So when we multiply, we don't want to change the value of the number that we're multiplying it by, because we don't have a value in the bottom of this fraction, or in the bottom of this number really. We're just putting it there to fill in that place and to represent that part of the fraction. Okay, so when we're multiplying and we don't want to change the value of the number, then we always are going to multiply by 1. When we're adding and subtracting, when we don't want to change the value of a number, we're adding or subtracting 0. But in multiplication, it's 1. Okay, so now we're going to label each part of this problem. So we have K, C, F, and then underneath it, not beside it, underneath it, we are going to keep, change, flip. So we have 1/2, keep this number exactly the same, change our division to multiplication, and we're going to flip the second number. So instead of 2 over 1, it would be 1 over 2. Now, when we flip this number right here, this is actually called the reciprocal, okay? The reciprocal of that number. When you have a fraction divided by a fraction, you'll actually have a fraction there, and that would be called the reciprocal fraction. Okay, when you flip it over, that's what it's called. That's the vocabulary word that we use. So in your upper level math, they're going to expect you to know and understand that that fraction flipped is actually called the reciprocal. So when you hear this in your upper level math, when you get to 6th grade, then they're gonna say multiply by the reciprocal. They're not necessarily going to say keep, change, flip. So I wanna make sure that I cover that, and I've talked about that so that you guys are familiar with it. So you're gonna multiply by the reciprocal fraction, or that fraction flipped, which does match our process of keep, change, flip. So then we're gonna multiply across the top and across the bottom. 1 times 1 is 1, and 2 times 2 is 4. So 1/2 divided by 2 equals 1/4. Okay, so that would be our answer. So let's talk about what this would look like in a model. Okay, so in a model, we're going to start with our whole, and our whole is cut into this number of pieces. Okay, so we're still working on 1/2 divided by 2. So we're going to start with this number. So if they ask you to write a number sentence for a model, you always have to look at what you started with. So here we're starting with 1/2. So we have to represent 1/2 in this fraction. So here we have 1/2. So now we've talked about the fact that the action taking place is division. And when we represent an action taking place, normally, typically, it is shown through a dotted line. That's how they represent. So we're going to take 1/2 and we're going to cut it into 2 pieces. Now, we cannot just cut it into the half into 2 pieces. We have to cut both pieces, the whole, into 2 pieces. So we have to continue this line all the way across. And then you may ask, why? Well, in order to understand our what is actually happening here, we're actually taking the whole. The whole is important. We're not just cutting the half into 2 pieces. We're actually cutting the whole into 2 pieces. So we actually are creating a new denominator here when we cut this into 2 more pieces. So now we can see the connection between our answer that we got up here and what we have here. Okay, so how many total pieces do we have now? We have 1, 2, 3, 4. So that is what creates our denominator of 4. Now, you may say, Ms. Hale, there's 2/4 there. Well, that is true. However, if this was a cake and you had half of a cake and you were sharing it with a friend, so that would be 1/2 divided by 2, right? So how much of the cake would one person get? That is what your answer is reflecting, okay? So how much of the cake is one person gonna get? They're actually gonna get 1/4 of the cake. So that's how we get 1/4 as our answer, okay? So now we could actually do this with a whole number as well. We're gonna flip this around and we're gonna do 2 divided by 1/2. Let's see what happens when we flip them around. So we're going to use the same process. Keep, change, flip. So make both numbers look like fractions. K, C, F. We're going to keep this first number exactly the same. Change our operation to multiplication and flip or create the reciprocal fraction for 1/2, which is 2/1. So then we multiply across the top and multiply across the bottom. So 2 times 2 is 4 and 1 times 1 is 1. Now, anytime we have a number over 1, that means that is actually equivalent to a whole. So we can drop that 1 off, because if we were to use the process of 4 divided by 1, we would end up with 4. So this is the answer to the problem flipped around. So now let's represent that one using a model. So we start off with what? We started with 2 as a whole number. So how many wholes are we going to create? That is correct. We're going to create 2. And how many pieces are we going to cut that whole into? Our denominator always tells us how many pieces we're going to cut this into. So we're going to cut each whole into 2 pieces. So now, how many 1/2s did we create in 2 wholes? 1/2, 1/2, 1/2, and 1/2. So how many total halves did we create? 1, 2, 3, 4. And that is how we got 4 as our answer. How many 1/2s did we create in 2 wholes? Awesome job, guys. I'm so proud of you. Great job.